Hi, this is Nestor. We're doing discrete structures. We're up to the homework for section 3.3, which is about matrices. Okay, so matrices, we saw what matrices are. The point is that there's going to be a lot of numbers, literally numbers, okay, multi-dimensional numbers. And so there might be mistakes. So before you yell and scream or whatever, if you think I'm wrong about something, look at the comments. Somebody yelled and screamed before you and found a mistake. So if I agree to a comment, or I say, yes, I made a mistake, then I made a mistake. I could have made a mistake that nobody else found either. So if you don't see something, send me an email or post it. Okay, but again, there will be mistakes because there's a lot of stuff going on. Okay? So the first thing is this problem, number one, and I simply forgot that A31 is 3. Okay, good. So first problem, A11. So A11 is 1. That's the first guy. Okay, next. A13, that's the first row, third element, is 5. A31, that's the third row, first guy, first row is 2. And then finally, the sum from 1 to 3. So 1 plus minus 2 plus 1 is 0. So the sum of I equal 1 to 3 of AII is 1 plus minus 2 plus 1, which is 0. Okay, so that was pretty simple. Next, part 3. They give you these 3 matrices. We don't need this. It's going to get things more complicated. They give you these 3 matrices and they ask you to do lots of different operations. So this is what it's all about. So A is A transpose. Little a is A transpose is also a 3 by 3 matrix. Okay, basically what's across becomes what's down. What's down becomes what's across. So minus 1, 0, 2, 1, 3, 2, and 2. 1, 3, 2, and 4, 2, 3. Okay. Let's just make sure we did that right. Minus 1, 0, 2, 1, 3, and 2. Minus 3, minus 2, and 4, 2, and 3. Yeah, I think that's right. Next, C transpose. So C transpose, so B is C transpose. C transpose, this is a 3 by 2 matrix. This is going to be a 2 by 3 matrix. And let's do it. So it's going to be 1, 2, 5, 3, minus 4, minus 2. Okay, great. Okay, number C. C is A plus B. So C is A plus B. Okay, so let's do it. Minus 1 and 6. So this is going to be a 3 by 3 matrix because this is 3 by 3 and this is 3 by 3. Minus 1 plus 6 is 5. 0 plus 8 is 8. 2 plus 5 is 7. 4 plus 1 is 5. 3 plus minus 2 is 1. Minus 2 plus 7 is 5. 4 plus 3 is 7. 2 plus 1 is 3. 3 plus 2 is 5. Okay, great. D is A plus C. A plus C can't be added. A plus C. A plus C can't be added, so I don't know what it's talking about. A is a 3 by 2 matrix. C is a 2 by 3 matrix. They cannot be added. Okay. A plus B transpose. Okay, number, that's D. So I don't know how to do D. Okay, something wrong with me maybe, but that's fine. E is A plus B transpose. Oh, look what it says. Calculate the following when they exist. It doesn't exist. So it doesn't exist. It doesn't exist. Okay, good. Next. E. E is A plus B transpose. So that becomes A plus B transpose. Take this and transpose it. So this becomes also a 3 by 3 matrix. Okay, because that's a 3 by 3 matrix, and it becomes 5, 5, 7. I'm reading it down, so that becomes a cross. 8, 1, 3, 8, 1, 3, 7, 5, 5, 7, 5, 5. Okay, great. F. Good Lord. Okay, I'm going to say F is also as follows. Well, this is also F. A transpose plus B transpose. Okay? Look, if you swap the A's and you swap the B's and you add them, it's the same thing as adding the A's plus the B's and then swapping them. So it's the same answer as that. So we're going to leave it alone. Okay? It's the same answer. If I got that right, then I got that right. Okay, and they want to show you that, so that's fine. B plus B transpose. Let's do that. Okay, so first, so now we're doing G. So let's do this. So here we have B. What's B transpose? B transpose is, let's do that. That's also a 3 by 3 matrix. Okay, and so that becomes 6, 4, 3. 8 minus 2, 1, 5, 7, 2. Okay, and now B plus B transpose is this plus this. So let's do it. 6 plus 6 is 12. 8 plus 4 is 12. That's nice. 5 plus 3 is 8. 4 plus 8 is 12. Minus 2 plus minus 2 is minus 4. 7 plus 1 is 8. Lots of 8s and 12s. 5 plus 3 is 8. 1 plus 7 is 8. 2 plus 2 is 4. Okay, that takes care of that. Okay, that was G. Okay, and C is C. Oh, C plus C transpose. Now let's see. C is a 3 by 2 matrix. C transpose is a 2 by 3 matrix. 3 by 2, 2 by 3. Anyways, they can't be added. They don't exist. So H is it doesn't exist. Okay, great. Okay, hold on. Okay, number 4. Number 4, we're going to do A and B. But so let's erase what we don't need. We're now up to number 4. I think I just erased A plus A. Shoot. Okay, we'll do. Oh, shoot. Okay, fine. Okay, great. So number 4 is A plus A. So they want, this is number 4, they want A plus A. A plus A is what? So I would rewrite A over here, and then we would do it. And so we get, they're both 3 by 3, so it gets minus 1 plus minus 1 is minus 2. Minus 1, 0 plus 0 is 0. 2 plus A is 2, is 4. 1 plus 1 is 2. 3 plus 3 is 6. Minus 2 plus minus 2 is minus 4. 4 plus 4 is 8. 2 plus 2 is 4. 3 plus 3 is 6. Okay, so that's 4a. Great. What about 4b? Okay, so that is 2a. Well, what does that mean? It means take every element of a and multiply it by 2. Guess what it comes out to be? Okay, it's exactly the same thing here. 2 times minus 1 is minus 2. 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. 2 times 3 is 6. 2 times minus 2 is minus 4. 2 times 4 is 8. 2 times 2 is 4. 2 times 3 is 6. Okay, it's exactly the same thing. Why? Because what this says is add every element to itself. This says multiply every element by itself twice. Every element by twice. So that takes care of that. Okay, great. 5a. Okay, so that takes care of 4. Next. Okay, there's nothing hard about this. Matrices are not hard. It's just a lot of bookkeeping. You got to keep track of what you're doing. You got to keep track of the rows and the columns. Okay? Okay. Okay, so number 5. 5, you have 2 matrices, and they are 4 by 3 matrices. So you're going to have a matrix A, and it's a 4 by 3. Okay, we're going to try to follow it. Okay, Aij is equal to minus 1 to the I plus j. Okay, so that's cute. I'll explain to you what that means in a second. What that means is as follows. Okay, well, this is the 1, 1 position. Minus 1 plus 1 plus 1. Minus 1 to the 1 plus 1 power is 1. Okay, good. This is the 1, 2 position. Okay, minus 1 to the 1 plus 2. 1 plus 2 is 3. Minus 1 to the third is a minus 1. Okay. This is going to be the 1, 3 position. That's 1 plus 3 is 4, so that's going to be even. Okay, great. This is going to be the 2, 1, that's going to be odd, so it's going to be like this. 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1. Let's just check with this one. This is the 1, 2, 3, 4, 1, 2, 3, 4, 3 position. So that's minus 1 to the 7th power. The 7th power is odd, so it's going to be a minus 1. Okay, great. Next, we also have B, and B is also a 4 by 3 matrix, 4 by 3. So it's also a 4 by 3 matrix, and it's defined as Bij equals I plus j. I plus j. So this is the 1, 1 position, so we put a 2. This is the 1, 2 position, we put a 3. This is a 1, 3 position, so we put a 4. This is the 2, 1 position, we put a 3. This is a 2, 2 position, we put a 4. This is a 5. This is a 4, 5, 6. This is a 5, 6, 7. Let's just check this. This is the 4, 3 position. 4 plus 3 is 7. So that's that. Okay, great. Next, they want you to calculate. We're doing 5A, D, and E. So 5A is A transpose. A transpose, 5, this is A. A transpose is, this is a 4 by 3 matrix, so we're going to have a 3 by 4 matrix, and basically it's 1, minus 1, 1, minus 1, minus 1, 1, minus 1, 1, 1, minus 1, 1, minus 1. That's A transpose. Okay, let's see. No, what are we doing? D. A D. Okay. D is A transpose plus B transpose. Okay. A transpose plus B transpose. Okay, so let's do this. This is equal to, well, I'm going to tell you, it's also equal to E, which is A plus B transpose. So let's first do what A plus B is. A plus B is, so A plus B is 1 to the y's. This is 3, 2, 5, 2, 5, 4, 5, 4, 1 and 6 is 7, minus 1 and 5 is 4, 1 and 6 is 7, minus 1 and that's 6. So that's that. And now we want A plus, plus B transpose is equal to okay, 3, 2, 5, 4, 2, 5, 4, 7, 5, 4, 7, 6. Okay, and that's equal also to that. I'm sorry, these two things are equal. If you add things and you transpose it, it's the same thing as transposing each one of them and adding them. Okay, so that's 5. Let's do 6. Okay, I messed up on the numbers. I called it something else, whatever, but let's do 6. We have two matrices, A and B. We're going to do all the parts of A and B. Okay, two matrices, A and B. Okay, and they're defined a certain way. We're going to calculate different things of them. Okay, let's do it. I don't know why I made this mistake. So AB is a 3 by 3 matrix where A is a 3 by 3 matrix where every one of the entries is equal to I times j. So Aij is equal to I times j. So let's see. This is the 1, 1 position. 1 times 1 is 1. This is the 1, 2 position. This is the 1, 3 position. This is the 2, 1 position. By the way, this is the 3, 1 position. 3 times 1 is 3. This is the 2, 2 position, that's a 4. This is a 2, 3 position, that's a 6. This is the 3, 2 position, that's a 6. This is a 3, 3 position, that's a 9. Okay? Okay, we can now answer part C. We can just look at this and answer part C, because part C says, question, is A equal to A transpose? And the answer is yes, it is. Why? Because, first of all, you can just see it right here. 2, 2, 3, 3, 6, 6, 9, 9. It's off the diagonal, everything is reflected. So that's easy to see. But another way to see it is A transpose of Ij, that is A of Ji, and A of Ji is equal to I times j, which is equal to j times I. Multiplication is commutative, so that's why that's the same. So that answers C. Okay, great. Okay. Now we do B. Let's do B. So we'll leave A over there. Now let's do B. B is also a 3 by 3 matrix, okay? And Bij is a little bit more complicated. It's I plus j squared. I plus j squared. So let's do this. This is the 1, 1 position. 1 plus 1 squared is 2. 1 plus 2 squared is 5. 1 plus 3 squared is 10. What's that? That's the 2, 1 position. So 2 plus 1 squared is 3. 2 plus 2 squared is 6. 2 plus 3 squared, 2 plus 3 squared is 11. 3 squared is 9, plus 2 is 11. Okay, this is the 3, 1 position. 3 plus 1 squared is 4. 3 plus 2 squared is 8. 3 plus 3 squared is 9 plus is 3 plus 9. 3 plus 9 is 12. Okay? Great. Okay, next problem. They want you to find A plus B. So this is, this is problem A. Oh, by the way, is this symmetric? No, it's not. 5, 3, no. 10, 4, no. 11, no. It's not symmetric. So part D asks if it's symmetric. Okay, B is equal, so this is part D. B is equal to B transpose, and the answer is no, it's not. Okay, and the reason is because I plus J squared is not the same thing as, if you swapped it, you would have J plus I squared. It's just not true. Okay, so these are not true, so it's not. Okay, so that takes care of C and D. Let's take care of A. Part A says add these two things. 1 plus 2, so this is A plus B is equal to also a 3 by 3 matrix. 1 plus 2 is 3. 2 plus 5 is 7. 3 plus 10 is 13. 2 plus 3 is 5. 4 plus 6 is 10. 6 plus 11 is 17. 3 plus 4 is 7. 6 plus 8. 6 plus 8 is 14. 9 plus 12 is 21. Okay, that takes care of that. Okay, and B is calculate the trace of this. So B is 1 plus 4 is 5, and 9 is 14. I want you to add these three elements. Okay, that takes care of that. That's the end of that. Number 7. Again, I could have made a mistake. Look in the comments if I made a mistake. Sorry, I'm not looking at you at all in this homework. It's just very technical, nothing hard. There's nothing hard here at all. Easy to do, just a lot of it. Sorry. I promise you matrices will show up in a million classes, in graphics, and databases, and everywhere. Physics, they show up all over. Okay, number 7. 7, consider the matrices. Okay, and here we have matrix multiplication. So we're in two small matrices. Okay, so this is number 7. And we're going to have matrix multiplication. We're going to do more matrix multiplication in this video. When we finish section 3.3, we're also going to do section 11.3, which specializes in matrix multiplication. Matrix multiplication is very important. Okay, A is equal to 3, 1, 9, 3. B is equal to 1 minus 2 minus 3 and 6. Okay, and so they want AB, they want BA, they want A squared, they want, okay, this is part D, B squared. Okay, so let's do it. AB is as follows. It's a 2 by 2 matrix times a 2 by 2 matrix. It's going to be a 2 by 2 matrix. I'm going to fill in this. So let's do this. So first row, second column. First row, first column. 3 times 1 times 3 plus minus 18 is minus 15. Okay. Next, minus 3 times, 3 times minus 3 plus 6 times 9. 6 times 9 is 54. 6 times 54 plus minus 9 is 54 minus 9. 54 take away 9 is 45. 45 plus 9 is 54. Good. Next, this is 1 times 1 plus minus 6. 1 times 1 is 1 times minus 6. 1 times 1 plus minus 6 is minus 5. And let's do the last one. Minus 3 plus 18 is 15. Okay? It pays to recheck that. So let's do it again. You ready? Boom, boom. 3 and minus 18 is 15. 3, so that's 54, and minus 9 is 45. 1, and so that's minus 5. Okay, that works. Okay, good. Okay, good. Let's do BA. So I'm going to have to rewrite it because otherwise things get messy. So let's rewrite it. Let's make sure we get the right now. 3, 9, 1, 3. 1 minus 3 minus 2, 6. Good. So this is 1 minus 3 minus 2, 6. Okay. 3, 9, 1, 3 is equal to. Okay, ready? 3 plus minus 3 is 0. 9 plus minus 9 is 0. That's interesting. 9 plus minus 9 is 0. 3 times minus 2 is negative 6 plus 1. 3 times minus 2 is negative 6 plus 6 is 0. 9 times minus 2 is negative 18 plus 3 is positive 18. Did I make a mistake? So that's all zeros. Make sure that works out again. 3 times 9. That works. Okay. Main point, A times B is not equal to B times A. Whenever you have numbers, usually when you multiply them one way or you multiply them another way, they're equal to each other, they're commutative. That works for numbers, a lot of numbers. It doesn't work for matrices. So that's the main thing. And this is fundamental, the most fundamental part of quantum mechanics, is the fact that this doesn't work. Okay, A squared. Let's do A squared. I have to rewrite it, otherwise I'm going to get confused. Again, I might have made mistakes, but I don't see what. Okay, so this is A, and we're multiplying A times A. 3, 9, 1, 3. This is equal to 9 plus 9 is 18. Okay. 27 plus 27 let's do that again. 9 plus 9 is 18. 27 plus 27 is 40, 54. 3 plus 3 is 6. 9 plus 9 is 18. Okay, that takes care of that. Okay, let's do b squared. Okay, we have to write it out. So this is 1 minus 3 minus 2, 6. 1 minus 3 minus 2, 6. Okay, so let's do this. This is also a 2 by 2 matrix. And so we get what? Ready? 1 plus 6 is 7. Minus 3 plus minus 18 is minus 21. Minus 2 plus minus 12 is minus 14. And then minus, oh, no, 3 times 9, plus 6, nope, plus 6 plus 36. 36 plus 6 is 42. Okey-doke. That takes care of that. Okay, number 8. And I regret erasing it. Okay, sorry I erased that. We're gonna have to do it all again. Okay, so let's do it. A equals, sorry, 3193. B equals 1 minus 3 minus 2, 6. Sorry. You all have it on your paper, but I have to read through it. Okay, so let's do it. That's a punishment for being stupid. Okay, let's do it. Okay, so first I want A plus B. Anyways, the answer at the end is that they're equal, but let's work it out. A plus B is equal to 3 and 1 is 4. 9 and minus 3. 9 and minus 3 is 6. 1 and minus 2 is minus 1. 6 and 3 is 9. Okay, that takes care of that. Good. A plus B squared is equal to, we have to write it out again so that we can not get confused, 4, 6, minus 1, and 9. 4, 6, minus 1, and 9. Okay, so 4 plus 4, I'm sorry, multiplying this out, so let's do it. 4 times 4 is 16, minus 6 is 10. Let's do that again. 4 times 4 is 16, minus 6 is 10. 6 is 24, minus 54. We have to write that down. 24 minus 54. Okay, we'll do that in a minute. Minus 4 plus minus 9 is minus 13. And this is minus 6 plus 81 is 75. 9 times 9 is 81. I'm sorry. Hold on. Minus 6 times 9 times 9. So, right. 81 minus is right. 24 minus 54 is negative 30. Okay. Okay, that's that. Okay, good. Now, let's do a squared. We did it already in last homework, but I erased it, so we have to do a squared. So a squared is 3193 times 3913. So that's equal to 9 plus 9 is 18. 9 is 27 plus 27 is 54. Okay. That's 3 plus 3 is 6. And that's 9 plus 9 is 18. Okay, good. I think b squared was the one that was all zeros. Okay. And finally, 2ab. So first of all, we have to do ab. So let's do ab. So a times b. I'm sorry, this is all part of the second thing. So let's do ab. So this becomes 3 and minus 18. 3 and minus 18 is negative 15. Minus 9 plus 54 is 45. 1 plus negative 6 is negative 5. Minus 3 plus 18 is 15. I think that's what we got last time. Okay, great. But we don't want AB, we want 2AB. Okay, so we just double every element here. So it's minus 30, 90, minus 10, and this is 30. Let's just make sure this is getting in the picture. Okay, it's there. Okay, so now we add these all together. A squared plus 2AB plus b squared is equal to, shoot. Okay, so now we have to add it. 3 plus minus 30 plus 0. Let's do that again. 3, oops. I'm sorry, 18 plus minus 30 plus 0. 18 plus minus 30 is 12. Okay, but I got a 10 over here, so that's not good. I think we have to multiply b squared again. Let's see if it works on any others. Let's see. 54 plus 90 is 145. Okay, we got to do b squared again. Hold on. 1 minus 3 minus 2, 6. So this becomes 1. Oh, so it's not. I was wrong. This is wrong. Okay. 1 plus. Let's do that again. 1 plus 6 is 7. So this is 7. Minus 3 plus minus 18. Minus 3 plus minus 18 is minus 21. Minus 2 plus 12 is minus, I'm sorry, minus 2 plus minus 12 is minus 14. Minus This is 3 times 2 is 6. 3 times 2 is 6 plus 36. 6 plus 36 is 42. Okay, so this is b squared. Okay, so let's forget about, let's erase it. No, let's forget about this. Okay, so now let's do this. This becomes, let's see if it works. You ready? 18 plus 2ab is minus 30, so it's negative 12. Negative 12 plus 7 This is too embarrassing. Sorry, sometimes you make mistakes. Anyways, so here's one mistake I made. This is 24 plus 54. 24 plus 54 is 78. So that's 78. Okay, now, what I thought was true and is not true, whatever, at a momentary lapse of reason, I thought that this would be equal to this. So we calculated this, and this is all correct, and then we calculated this, and it's not the same as this, so I got nervous. So let's just do it anyways, because I was wrong. They're not equal, okay? And we have to go through that. Okay, so let's do a squared plus 2ab. We have 2ab plus b squared, and I did it already. Okay, and so we get minus 5, 123, minus 18, and 90. Let's just do the 90. A squared is 18 plus 2ab is 30. 18 plus 30 is 48 plus, where's b squared? Plus 48 plus 42. 48 plus 42 is 90. So that's that. Okay, so that works. Okay. Anyways, main point, and this is what they asked you to do, is this equal to this? And the answer is no, it's not equal to that. Okay. But I would like to spend a minute showing you what is equal to this. Okay, and the idea is as follows. We can go over here. We don't need this room over here. We did till 8, so we can do this over here. Okay. When you were in 3rd grade, 4th grade, you learned about FOIL. Well, FOIL doesn't only work with multiplication, it also works with matrices. Okay, so when you multiply this, you get what? A times A. First, outer, inner, last. First, A squared. Outer, AB plus AB. Inner, plus BA plus B squared. Now, usually you say, oh, these are numbers, very good. So AB and BA, those are the same thing. So you get A squared plus 2AB plus B squared. Okay, but that's not true here. AB is not necessarily the same thing as B squared, BA. AB and BA is not necessarily true, that they're equal. With matrices, what I just said 5 minutes ago is that it's not commutative. So what we do have is the following rule. A plus B squared is equal to A squared plus AB plus BA plus B squared. Okay? Not equal to this. Okay, and we can actually calculate that. This will take 1 second to calculate it. Let's actually do it. Okay, so this is A squared plus AB plus B squared, BA plus B squared. Now, if you remember, BA was that stupid matrix 0, 0, 0, 0, so we don't even have to deal with that. We should get this. Anyways, look at that. Let's do it. This is equal to, also a 2 by 2 matrix. A squared is here, 18 plus AB, that's here, 18 plus minus 15 is 3, plus BA is 0, B squared is 7. I messed up already. Let's do that. 18 plus minus 15 is 3, plus 7 is 10. That's exactly what we have here. Next, A squared. Let's do 54 plus 45. That's 99. Plus minus 21. 99 minus 21 is 78. Exactly. Let's do that. I love when things work out. You ready? 6 plus minus 5 is 1 plus minus 14. 1 plus minus 14 is minus 13, which is exactly what we had here. And let's do the last one. You ready? 18 plus 15 is 33 plus 33 plus 42 is 75. So it works. So these two are equal. A plus B squared is equal to A squared plus AB plus BA plus B squared. Here we had a very easy BA because it was zeros. Okay, that takes care of that. Okay? Okay, we have more room now. Hope I'm erasing legally and we don't need anything. But that takes care of that. That's number 8. Number 13. Okay. 13, they want us to do some rules. 13, they want us to do that C times A plus B times B is equal to CA times A plus CB times B. Okay? Okay. Look, what's this? Each element here is going to be AIJ. Okay? And you're going to multiply it by A, and you're going to add it to B, and then you're going to have a matrix. So each element of the matrix is going to be Bij. Okay? And you're going to multiply that by C. Okay, now these are, I'm talking about one element of the matrix. Each element of the matrix is going to, the ijth element of the matrix is going to be this. Now you're multiplying by C. Well, this is regular numbers, multiplying the numbers, and you have x times y plus z is equal to distributive property x times y plus x times z. Okay, so this is going to become C times Aij plus C times Bij. Okay, and that is exactly this, and this is exactly that. Finished. Okay, each one of these elements is going to be what? You're going to take C times A, and you're going to multiply it by the ijth position, Aij. You're going to do C times, add them, plus C times B times Bij. It's exactly the same. Okay, so that's 13A. Okay, that's good. Part B, we want minus AA is equal to, minus A times A, which is equal to A times minus A. Okay, let me just say, so what is this? This is probably like this. Okay, what that means is take the entries in A, multiply them by small a, and put a negative in front of them. That's the same thing as multiplying every entry by negative a, which is the same thing as taking the entries, put a negative in the front of them, and doing that. In other words, in all three of these, you have an entry called the ijth entry, and you're multiplying it by a and with a minus. Now you can put the parentheses around here. You can put the parentheses around here. This is, or you can even look at it like a minus aij. Okay, so all three same ways of looking at things. Okay, next, part C is that A transpose is equal to A transpose, A transpose like that. I think there's three ways of doing it. Okay. In the book they don't have this, but it's because they have some. Okay, anyways, the point is as follows. What is this? Okay, well, the ijth position of this matrix is what? A transpose with an A. The ijth position is equal to AJI. That's the swapping multiplying by A. Okay? So basically it goes as follows. Look, what are you doing here? You're multiplying every entry by small a. Good, you multiply every entry by small a, and then you swap it. Well, that's the same thing as swapping each one of them and multiplying by a. It doesn't matter when you multiply every entry by a. So that works. Okay, good. Anyways, the next four problems, 15, 16, 17, and 18, are connecting the world of matrices and the world of graphs. Okay, so in 15 and 16 we give you a graph, we ask you for the matrix that corresponds to it, and in 17 and 18 we give you the matrix and they ask you for the corresponding graph. Okay, so let's do 15a. I just want to draw the picture. So this is V1, V2, V3, V4, and you have an arrow like this, you have an arrow like this, and you have an arrow like this, and this is 15A. Okay. And so what do? So this is going to correspond to a 4 by 4 matrix, and you can write the 4 by 4 matrix as follows: V1, V2, V3, V4, V1, V2, V3, V4. Now let's see. There's an arrow from 1 to 3, so we're going to write that like here, 1. Now it could be, it's probably this. There's an arrow from 2 to 3, so that's like that. There's an arrow from 4 to 3. So that, okay? There are no other arrows. Okay, so all the other entries are 0. And that's it. That's 15A. Great. Now let's do 16. So that was a directed graph. Now we're going to do an undirected graph. So again you have V1, V2, V3, V4, V1, V2, well, you know what? Okay, let's do it. V1, V2, V3, V4. Let's copy over what it says in the book. From 3 to 4, there's a dot. From V1 to V3, there's a dot. From 1 to 2, there's a dot. This has a circle around it. This has 2 circles around it. Okay? Now, what matrix corresponds to this? This is 16A. What matrix corresponds to this? Well, let's do it like this. M is the matrix. It's going to be a 4 by 4 matrix. I'm going to write it like this. Okay. So, from V1 to V1, there are two edges. From V1 to V2, there's one edge. From V2 to V2, there's one edge. From V1 to V3, there's one edge. From V3 to V4, there's one edge. Everything else is 0. Whoops, sorry, hold on. This is not directed. So not only is there an edge from V1 to V2, but there's an edge from V2 to V1. Not only is there an edge from V1 to V3, V1 to V3, but there's one from V3 to V1. There's an edge from V3 to V4, but there's one from V4 to V3. Okay, this is wrong. We messed up. Okay, V1 to V1 is 2. V1 to V2 is 1. V2 to V2 is 1. V1 to V3 is 1. V3 to V2 is 1. V3 to V1. V3 to V1. V2 to V1 is 1. V2 to V2. Okay, now it's good. Okay. Okay, great. Let's do 17. 17, they go the other way. They give you the matrix and they ask for the graph. So 17a goes as follows: 0, 0, 2, 1, 3, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. That is the matrix. Okay, it is not a symmetric matrix, which means it's not the same as the diagonal. If you leave out the diagonal, it's not the same. Okay, we can put that as V1s again. V1, V2, V3, V4, V1, V2, V3, V4. Okay, and I don't know what the graph's going to look like, but it's going to be something with 4 vertices. Let's write it: V1, V2, V3, V4. Let's see what this says. There's 2 vertices from V1 to V3. Okay, they put their arrows in the middle of the line. I'm not used to it, but we'll do it. There's from V1 to V4, there is an arrow. Great. From V2 to V1, there are 3 arrows. Arrow, arrow, arrow. From V2 to V4, from V2 to V3, there's 1 arrow. So we're going to make it like that. Okay, from V3 to V2, there's 1 arrow. So there's one going this way, there's one going that way. That's V3 to V2. From V4 to itself, there's an arrow. Doesn't matter what way they put that arrow. Okay, so that takes care of that. That's 17A. Okay, great. Now 18. Okay, I just did B instead of A, 18B, so we're doing 18B. Okay, again, it's a 4 by 4 matrix, and it's going to correspond to a graph that has 4 vertices. Okay, let's do it. 0, 0, 1, 2, 0, 0, 1, 2, 0, 1, 0, 1, 1, 0, 1, 0, 2, 1, 0, 0. Okay, so let's do it again. 4 vertices. I don't know how it's going to look, but might as well try this. We have to stretch it out. Okay, from 1 to 3. Okay, this is a symmetric matrix. Whoa. Yeah, that's a symmetric matrix. So we're just talking about edges, not directed. We're going to get a graph, not a directed graph. So we're going to get from 1 to 3, from 1 to 4, 2 of them, from 2 to 2, 1 of them, from 2 to 4, 1, from 1, well, that's it, I think. From 3 to 1, we got 1. From 3 to 3, we get 1. From 4 to 1, we have 2. From 4 to 2, we have 1. That's it. Okay, that's N for my first name. Okay, so that's the end of 3.3. Now, we go, I made one video for section 3.3 and 11.3. Section 11.3 is an application. We take this matrix multiplication and we do more of it, and we find applications. So it's very, very, very related, and I want to make it as one video. So let's continue. So, section 11.3, which is called multiplication of matrices. Okay, multiplication of matrices. Okay, and we're doing the homework of that, and of course you do the homework first, and then you check the answers. And the homework problems are 1, 3, 4, 11, and 13. Okay, so it's a lot of matrix multiplication, nothing hard, but I could have made mistakes. So that is life. Okay, so let's do 1. Ready? Okay, A is equal to 1, 2, 4, 3, 0, 2. B is equal to 2 minus 1 minus 2, 1, 0, 3. Okay. Okay, so let's do it. A, B, C, D, E, F. Let's see what they're asking for. He's asking for AB. He's asking for BA. He's asking for AB, A. He's asking for A plus B transpose. He's asking for 3A transpose minus 2B. And this one's asking for AB squared. Okay, now I can put the book down, we can work it out. Okay, so let's go through this. This is a 2 by 3 matrix. This is a 3 by 2 matrix. So that we're going to get out a 2 by 2 matrix. Okay, let's go through that again. This is a 2 by 3 matrix. This is a 3 by 2 matrix. We're going to get out a 2 by 2 matrix. Let's do it. First row, first column is 2 minus 2 is 0. That's a minus 8. minus 2 times 4. This is going to be a 1 plus 0 plus 12 is 13. It's going to be a 2 times 3 is 6 plus 0 plus, I'm sorry, 2 times 3 is 6, minus 4 is 2, and this is going to be a 3 plus 0 plus 6 is 9. Okay? Okay. BA is harder to see. Oh, I'm sorry, BA can't be done. Oh no, BA can be done. Okay, this is going to be a 3 by 3 matrix. Okay, but I have to rewrite it here. So let's rewrite A. I need to have it on this side, otherwise I screw up. So I'm going to write it 1, 2, 4, 3, 0, 2. Now I'm multiplying this times this. Ready? It's a 3 by 3 matrix. Okay, you get 3 by 3 matrix. So let's do it. This is 2 and 3 is 5. This is 4. This is 8 and 2 is 10. This is minus 1. This is minus 2. This is minus 4. This is minus 2 plus 9 is 7. This is 4. This is minus 8 plus 6 is minus 2. Could have been wrong there. Okay, great. Let's do this. This is a 2 by 3 matrix. B is a 3 by 2 matrix. Okay, A is a 2 by 3 matrix. Okay, and so basically you're going to get out a 2 by 3 matrix. Okay, so we're doing part C now. Okay, and the way we calculate it is as follows. We're going to do A times B and then multiply A by it. So it's going to be minus 8, 13, 2, 9, that's AB, times, I'm going to put an A again. So this becomes 1, 2, 4, 3, 0, 2, and we get out what? Okay, let's do this again. This is a 2 by 2 matrix. This is a 2 by 3 matrix. So we're going to get out a 2 by 3 matrix. Okay, so let's do it. Minus 8 plus 3 times 13. Minus 8, so 39 minus 8 is 31. Okay, that's a 2, that's a 0. Okay, let's do this. This is going to be minus 16 plus 0 is minus 16. Okay, great. This is 4 times minus 8 is negative 32. Negative 32, negative 32 plus 13. Okay, so it's going to be 32, so that's going to be 19. So it's going to be negative 19. Yeah, I think I'm right. Okay, next. Down. 1 times 2 is 2. So 27 is 29. 4. 8 and 18 is 24. Let's do that again. 4 times 2 is 8 and 18. 8 and 18. 18 and 8. That's a 6, sorry. That's a 26. Okay, that takes care of that. Okay, A plus B transpose. Okay, so let's do that. A plus B transpose. Let's just do B transpose here. B transpose is 2 minus 1 minus 2, 1, 0, 3. And now we do, okay, finish that. A plus B transpose is going to be a 2 by 3 matrix. And we do it. 1 plus 2 is 3. 2 plus minus 1 is 1. 4 plus minus 2 is 2. 3 plus 1 is 4. 0 plus 0 is 0. 2 plus 3 is 5. Okay. Okay. Anyways, we don't need this. You can look at this later on the video. So, but I can erase this and get some room. Okay. So let's do A transpose. Let's do this. A transpose is this. 1, 2, 4, 3, 0, 2. Okay. Three A transpose is equal to 3, 9, 6, 0, 12, 6. Okay, now 3A transpose. This, oh, I'm sorry, hold on. Let's do 2B. 2B okay, is 4, 2, minus 2, 0, minus 4, 6. Okay, and now I do this minus this. So we get this is equal to, let's go, 3 minus 4, negative 1. 9 minus 2, 9 minus 2, 9 minus 2, 7. 6 minus 2 is 8. 0 minus 0 is 0. 12 minus 4 is 16. 6 minus 6 is 0. Okay, great. Next. Again, I could have made a mistake, but could not have made a mistake. Next. Okay. Okay. We have AB. Now we want AB squared. So it's minus 8. Whoops. So we have to multiply AB times AB. So this is minus 8, 13, 2, 9. Okay, so this is equal to minus B squared. So this is, let's do it. 8 times 8 is 64. You need a calculator here. 8 times 8 is 64, so this is going to be 64 plus 13 plus 26. Okay, this is going to be minus 8 times 13 plus 9 times 13. Great. This is going to be minus 16 plus 18. And this is going to be 26 plus 81. 9 times 9 is 81. Okay, and this is equal to 60, 70. I'm sorry, 80, 90. Okay, this is going to be a 2. This is going to be minus 8 times 13 plus 9 times 13 is 13. So minus 8 plus 1 is 9. I'm sorry, is 1. 1 times 13. Okay, and 26 plus 81 is 107. Okay, so that takes care of that. Okay, great. That's 1. Let's do 3. Again, nothing hard, just lots of tedious things. Okay, next, 3. Okay, but we're not going to erase number 4 because we need number 4. We need 3 for 4, so let's do it. Ready? So this is number 3. And I promise you on a test question, I promise you I'm going to give you 2 matrices and ask you to multiply them out. I'm going to guess something along these lines. So let's do, you ready? Number 3. A equals 3, 2, minus 1, minus 4, 0, 1, 3, 1, 2, 1, minus 2, 0. Okay, B equals 1, sorry, minus 1, 1, 0, 1, 2, 1, 0, 1, minus 1. Okay, great. So first they ask for a squared. Now that's a pain in the neck. So let's rewrite a. Oh, a squared. That's not possible. Why? Because this is a 3 by 4, and this is a 3 by 4. They don't multiply. So a squared. So a squared does not exist. That's nice. B. B squared. Oh, B is a 3 by 3 matrix. 3 by 3s can easily be multiplied by 3 by 3s. Well, easily, but lots of work. So let's do it. Minus 1, 1, 0, 1, 2, 1, 0, 1, minus 1. Let's multiply it. This is B squared. So we're going to get out a 3 by 3 matrix. Let's do it. 2 minus 1 plus 2 is 1. 1 minus 1, 2 minus 1 plus 2 is 1. 1 plus 4 is 5. Oh, 1 plus 4 is 5, plus 1 is 6. 2 plus minus 1 is 1. Okay, great. Next, that's going to be a 1. 2 minus 1 is 1. 1 plus 1, that's a 2. That's B squared. Again, I could have made mistakes. That was a little bit quick. Okay, AB. AB. Let's do AB. Let's do this. This is part C. AB. Let's just make sure we got this right. This is a 3 by 4. Right? This is a 3 by 3. Doesn't work. Does not exist. Okay, D is BA. BA. Let's see that. That's going to work because B is a 3 by 3 matrix and this is a 3 by 4 matrix. So we're going to get out a 3 by 4 matrix. That's a lot of work. Okay, let's do it. Minus 3 plus 2. Minus 3 plus 2 is minus 1. 4 plus 4. It's a minus 3 plus 1 is a minus 2. And this is going to be a minus 1 plus minus 2 is minus 3. Okay, and this is going to be a 3 plus 4. I'm sorry, 3 plus 4 is 7, minus 1 is 6. 6. Okay, this becomes minus 4 plus 1 is minus 3. And this becomes 3. 1 times 2 is 2. 3 plus 2 is 5. Plus 2 is 7. And this becomes 1. Minus 4. 1 minus 4 is negative 3. It's negative 3. Two plus 1 is 3. Minus 1. 1 and minus 2. 1 and minus 2 is minus 1. Minus 2. Okay, that's what I got. Okay, that's 3. Let's do number 4. Don't erase. Number 4. Let A and B and find the following matrices. BA squared. BA transpose. So now we're doing number 4. BA transpose. So BA transpose, let's just do this. B is 3 by 3. 4 is 3 by 4. Transpose, so this is a 4 by 3. So 3 by 3, and this is a 4 by 3. Ain't happening. Does not exist. Does not exist. A transpose B. Let's see what A transpose B. A transpose times B. This is, let's do this. This is going to be, A is a 3 by 4, so this is going to be a 4 by 3. Okay, times 3 by 3. So that will work. So let's do it. We have to first calculate what A transpose is. So let's do this. A transpose B is equal to 3 minus 4, 3, 1, 2, 0, 1, minus 2, minus 1, 1, 2, 0, okay, times B. Minus 1, 1, 0, 1, 2, 1, 0, 1, minus 1. Okay, so this is a 4 by 3, and this is a 3 by 3, so we're going to get out a 4 by 3. Okay, let's do it. Pain in the neck. Minus 3 plus 2. Minus 3 plus 2 is minus 1. 3 plus 2, so this is 3 plus 4 plus 3 plus, that's a 6. 2 plus 1 is 3. 4 plus 0 plus 0. Minus 4 plus 1 is minus 3. minus 1, so minus 3 plus 1 is minus 2. Minus 2. 3 plus 2 is 5. Plus 2 is 7. 0, 1 plus minus 2 is minus 1. Okay, bottom row. Minus 1 plus minus 2 is minus 3. Minus 3. Minus 1 plus minus 4. 1 plus minus 4 plus 0. So 1 plus minus 4 is minus 3. 0. That's a minus 2. Okay, that takes care of that. Okay, 5AB transpose minus 3B squared transpose. Okay, anyways, A is 3 by 4. AB, this is a 3 by 4. This is a 3 by 3. They can't be added. So 5AB transpose minus 3B transpose A transpose, it doesn't matter about this. I'm not interested in this. I'm not interested about this. Look, this doesn't exist, so the whole thing doesn't exist. So part C does not exist. Finished. Okay, we are finished 4. Now we're doing number 11. Okay, number 11. Okay, so this is the main application that I wanted you to see, but matrix multiplication has applications all over. Again, in graphics, in physics, in databases, etc. It's a very, very common feature. So let's do this. We're up to number 11, and basically they will give you the matrix and they want you to find m squared. So let's do it. 2, 7, 1, 2. So m equals 2, 7, 1, 2. 0, 4, 0, 0, 0, 4, 0, 0, 1, 3, 1, 1, 1, 3, 1, 1, 0, 2, 0, 0, 0, 2, 0, 0. I'm going to do 2 of those. 2, 7, 1, 2, 0, 4, 0, 0, 1, 3, 1, 1, 0, 2, 0, 0. We're going to get out a 4 by 4 matrix. This is a graph with 4 by 4. Okay, I'm sorry. Okay, but oh, I'm sorry. I made a mistake. Sorry, number 11. Let M be the adjacency matrix for the digraph in example 1. Okay, example 1. Okay, so this example 1 is right over here. Nice little picture. Okay, now look what they're doing. They did all the work already. M squared. They're giving you M squared. That's stupid. Okay, they're giving you M squared. I won't do this on the test. I will ask you to work it out. Use m squared to find the number of paths of length 2 from V1 to itself. Ready? From V1 to V1. So let's just put in this because it makes things easier. V1, V2, V3, V4. From V1 to itself is 2. That's it. Next. From V1 to V3. That's this. Next, from V1 to V4, that's this. Next, from V2 to V1, V2 to V1. 0. That's it. That's the end of that. Number 13. Good Lord. Okay, so let's do this. Basically, they want us for number 13. Okay, we're doing number 13 now. Calculate M3 for the adjacency matrix in example 1. So, we calculate, this is M2. Okay, let me tell you what M3 is. M3 is M2 times M. Okay, that's M3. So we know what M2 is. Now we just have to put in another thing called M. So this is M2, and now we're going to do M. Okay, and we know what it is. So let's do it. Example 1, it's right there. It's 1, 2, 1, 1. 1, 2, 1, 1. It's on page 440. 0, 2, 0, 0. 0, 2, 0, 0. Next, 1, 0, 0, 1. 1, 0, 0, 1. And finally 0, 1, 0, 0. 0, 1, 0, 0. Okay, now I don't want to calculate all 16 things. All it says is find the number of paths of length 3 from V3 to V2. So, well, this is going to be a 4 by 4 matrix, but they want from V3 to V2. Okay, so we want this position. So I don't have to calculate the whole thing. All I have to do is look what the third row, the second column, and multiply them out. 2 times 1, 2 times 1 is 2. 2 times 3 is 6. 0 times 1 is 0. 1 times 1 is 1. So it's going to be 2 plus 6 plus 0 plus 1. So 2 times 2, that's 2. That's 8. 2 plus 3 is 8 plus 0 plus 1 is 9. 9. That's it. Okay, the next thing is to list them off. I'm not going to do it. It's just too painful. Okay, anyways, but it's very nice. Okay, we did some of that in class and we listed them off in class. It's very nice. All right, so that takes care of section 3.3 and 11.3. Have a nice day.